Welcome to a tutorial video on circuit theory, and in this video what I'm going to do is I'm just going to introduce you to the concept of solving a network using the superposition theorem. Okay, so let's just first bring the problem statement. Okay, so here's our problem statement, and it says that find the potential drop V, okay, across the 10 ohms resistor. Okay, so right here we have a 10 ohms resistor, and of course then it should have this it should have a potential drop of let's say V volts across it. Okay, so find the potential drop V across the 10 ohms resistor for the circuit given alongside using superposition theorem. So this is exactly the important part of the problem. So there are a number of network theorems, so you'll always need to keep your focus on which type of network theorem they just tell you to use. Okay, so just keeping in mind this problem statement, so what are we waiting for? Let's just go forward and apply that. Okay, but before we move on to the very first step of applying the superposition theorem to the circuit, okay, we need to keep in mind that we can see here that there are two sources. Okay, so we have a voltage source over here on the left, and then we have a current source on the right. Now we can go forward and start up with any one of the sources. We can just go forward and eliminate any one source and just find the necessary voltage developed across this 10 ohms resistor for the other one. Okay, so let's just first name the terminals over here. Let's just call this terminal as, let's say, terminal A. Okay, or rather that's A is not so clearly visible. Okay, so that's better. Yeah, no, that's better. And let's just call this terminal as, let's say, terminal B. Okay, fine. So we have two nodes known as nodes A and B. Okay, so let's just first start with eliminating the current source over here. So that's gonna be our step one, and we're gonna modify the figure for that step. Okay, so here's our modified figure once again. Okay, we just eliminated the current source from the circuit diagram totally over here. So now what we have left over here is the 10 volts voltage source over here. And now as the superposition theorem states that you got to find out the necessary voltage drop that would occur, or rather let's just find out the current that would just flow through this 10 ohms resistor, since you're going to need the current that should flow through this. Okay, let's just call this one as the okay, so due to this 10 volt source there would be a current flow in the circuit. Let's just call it I1. Okay, and the same I1 would enter over here. So what we are going to do over here is that we're going to find the current that should enter into the 10 ohms resistor due to this 10 volt voltage source over here. So let's say, so here we're going to find the I1. Okay, that's the current developed due to the 10 volt source over here. That's going to enter the 10 ohms resistor. Okay, so just keeping that in mind, let's just go forward and solve this over here. So we're going to get I1 as equals to be, I1 should be equal to, let's just write down the KVL equation first. Okay, so from KVL, we can just write that 10 volts is equals to the voltage drop across that of the 5 ohms resistor. That would be given by 5 multiplied with this current, that's I1, flowing through the 5 ohms resistor, and it'll also flow through the the 10 ohms resistor as well. So we got 10 multiplied with I1 as well. So since 5 and 10 ohms are in series, as you can see clearly from this figure. So if we just go forward and modify the equation over here, so we can clearly get, or rather make I1 the subjective formula, and we can get 10 divided by 5 plus 10. So that makes 10 by 15. So this much ampere of current would just pass through the 10 ohms resistor upon the inclusion of only the 10 volt source. Okay, and if we just try and find its value in decimal, then or rather let's just not go into that details over here, so let's just keep it that way, or rather we can just also reduce it and make it as 2/3 amps. Okay, that's better. So here we have the value of I1, which is of course 2/3 amps. Let's just keep that in mind. And from here on, we'll just go forward to step number 2, where we shall be excluding this 10 volt source over here and including the current source. That's 5 amp current source. The 5 amp current source that we have on the right. Okay, so let's just remodify the figure again. Okay, so we've reached step 2 over here, and now we have remodified the figure once again, and I can see that since we're supposed to short voltage sources and open the current sources, so that's what we did back in the last step. That's step 1 over there, and now we have just eliminated the voltage source. That's 10 volts over here. If you'll just take a look at the original figure that we have over here, so this is the original figure, okay, and we had done this in case of step 1. We just eliminated the current source just by opening the part of the circuit on the right, and over here now in step 2 we've just shorted the voltage source, and now only the current source is there, which will basically supply the current in this part of the circuit. Okay, so let's just assume that in this part over here we'll have this as node A and a node B once again, and now since this 5 amp current would obviously divide itself back in the 5 ohms and the 10 ohms resistors. Okay, so what we need to find out over here, we need to just find out the current that would flow through the 10 ohms resistor. So let's just call this one as, let's say, I2, no problem. So we can just directly find out the value of I2 using the current division rule. So let's just write it down over here. So from current division rule, that's what I'm gonna write down over here. So current division rule. Okay, so that's written over here. So from current division rule, what we can see is that, let's just pull the page down a bit. Okay, that's better. So what we have over here is that from this particular rule is that we can just write down I2 is equals to the total the current that should enter, the total current that's being supplied into both the arms of the parallel resistances that we can see over here. So that's the total current over here. That's the 5 amps being supplied from the current source. So we have the source current multiplied with the 5 ohms over here. Okay, and that divided by the sum of both the resistances, as you'll find out shortly. So we can just write down as 5 plus 10. Okay, so that just gives us 25 by 15. So we can also go forward and reduce it to find, that's 5 by 3. So we can just write down as 5 by 3 amps of current that we're getting. Okay, so now from the theory of superposition principle, we can just find out the net current that should enter into this 10 ohm circuit. Okay, so let's go on to step 3. Okay, here we are at step number 3, and now as the superposition theorem states that now we know the currents that would enter into the 10 ohms resistor. Let's just call this one as I. Okay, and now we'd seen back in step 1, the current that's entering over here is given by I1 due to the 10 volts voltage source. Okay, that's about 2/3 amp. And in step number 2, we'd seen this that's due to the current source of 5 amps. The amount of current that's entering over here, denoted with the symbol I2, is about 5 by 3 amps. So we can just go forward and write down that from superposition theorem. Okay, so from superposition theorem. Okay, that's quite a long name over there. So it's gonna take some little time. Just kind of be patient with me. So that's from superposition theorem. We can basically write that the value of the net current that should enter into the 10 ohms resistor will be given by the sum of the I1. Okay, that's the current due to the voltage source, and also the current due to the current source that's given by I2. Okay. So let's just go forward and add them together. So let's just put the values of the I1 over here. So I1 is about, let's take a look again. It's about 2/3 of an ampere. Okay, so we're just gonna write it down over here, the 2/3 amp, and I2 is about 5 by 3 amps. Okay, so if we go forward and add them together, we're gonna get we're going to get about 7 by 3 amps. So that just makes up, that's just going to let's just keep it that way. Let's just not go into the decimal part. So now what we need to find over here is that we need to go and find the voltage that develops across the 10 ohms resistor due to the net current of I that's going to flow through this 10 ohms resistor over here. So well, the net voltage that we'll find out over here would be given by the product of the net current, that's I, multiplied with this 10 volts resistor. Okay, sorry, there 10 ohms resistor. That's just a slip of tongue over there. So if we just put the value of I over there, we're going to get, well, 7 by 3 amps multiplied with 10. So that just gives us about, well, 70 by 3. So that's going to be about, well, 23.33 volts that we should get for the voltage drop across that of this 10 ohms resistor. Okay, so in 3 steps you've solved a network using superposition theorem. So that's great, I guess. So now we have the our required result over here. Okay, and with that we just come to the end of our tutorial discussion on the superposition theorem. So let's see you just in the next tutorial once again. Okay, hope this tutorial has been, well, helpful to you all, and till then it'll just be a short goodbye for now, and it's of course a thanks for watching.